Alright, so here we're going to teach of single view vision process. So a 2D single view vision process. So the first thing we want to do is set our frame. So I'm actually using frame 6 here, and I've got my grid set up. And so frame 6 is set up to be to match our grid. And so before you do anything else, you just want to make sure that your frames are what you expect them to be. So I'm just going to use the move to function here and go over here and just kind of show you that that is in fact my origin point, and I can go to my X point and go to the Y point. So go to the Y point, so you can see that I use the 3-point method here to teach the frame. And so the grid that we're looking at matches the frame. And so the next thing that we want to do is teach the robot to pick up a part. Okay, so we want to teach the robot to pick up a part, or in this case I just have pointers attached. So I'm going to teach the robot. So I'm going to teach the robot to see the part. All right, and so what I've got here is I've got this little smiley face that I'm using. And the smiley face here that I'm just using to teach this, I'm going to teach to go to the right eye, and so I'm just going to line that up on my grid. So when you teach a part, you want to teach it to come to, you want to teach it to match your grid. Okay, now this grid, we need to make sure you calibrate the camera to your grid. I've done that in a separate video. So I'm not going to do that right here. That's already been done. But I'm going to teach this part. But before I teach the part, I'm going to write a program to come over here as if I was going to pick this up. And so we need to come over. We need to use a tool offset and then come down to the part and then return to our tool offset and move off to wherever it's going to go if it was actually picking up the part to stack it or place it inside of a CNC machine or robo drill or something of that sort. All right, so we're going to go here. I've already actually created the program. The first thing I'm going to do in my program is use the frame commands to set my frames. I'm actually using tool frame 6 and user frame 6. And then we need a tool offset. So I've got my position register here, and I'm just zeroing it out. So this I'm going to use position register 100 for my tool offset, and I'm just using LPOS minus LPOS, which is going to zero out my position register. And this is going to be a tool offset, so I'm going to set the Z then, set my Z value to be minus 100 millimeters, so it'll be 100 millimeters above my frame. Remember, this is my frame, plus Z is up for the user frame, but remember this is I'm going to use a tool offset here, so using the tool offset I'm using a minus Z because it's going to be the offset from the robot. So then I have a home position here, so I'm actually going to label this as home position. Okay, this is just going to be a home point, and the most important, there are two major points about this home point is that number one, that this point is out of the way so that the camera can take the picture, and it's also away from any objects that, it's out in a clear area so we can take the picture. It's not obstructing the view from the camera, and it's not near an object, so it's not going to hit any object. So we're going to start the program basically by After we set our frames and initialize our tool offset position register, we're just going to make sure the robot is in the home position in case it wasn't left there. Then we're going to have a label here, so we're going to loop through the program and we're going to return back here. And then I have a wait statement here. Now, a lot of times you may not want to wait, but in this case, what we're going to do is we're going to be moving our objects around or taking them away and putting them back, kind of thing. And so what we need to do is just give it a little bit of time so we can kind of move it around when we're testing the program. And so that's what I have the wait for in here right now. So it's not really a critical wait. And then we have the vision commands. Now, at this point, okay, I don't want the vision commands, so I'm actually going to delete these out of here for the moment. Should have deleted both of them at the same time, but I didn't. So, and then we're going to have our thing. Now I've got the vision offset here. I'm going to take those away. Okay, so I'm taking those away because I just want to show you the main program. So I'd already had this working, and all right, so but here's my program. So what I'm going to do in this program is I have 2 points. I have the home point, and then I have another point which turned out to be point 6 because I started this program from another program here. So I have this other point is point 6, which is actually just my second point in the program. But I have here on line 8, I have a tool offset. So I'm going to be 100 millimeters above. And then I'm going to come down to the, and I'm actually going to come down to the eyeball, the pupil there. And then, so I'm going to be 100 millimeters above it using this tool offset. Then I'm going to come straight down to it. Slow down a little bit as we come down to it. And then I'm going to turn on a light. So I'm going to turn on a light there, and then I'm going to wait about half a second. At this point, I'm going to wait about half the second as if I was opening or closing a gripper, and then I'm going to move off. And so I'm going to move back to my offset, and then in this program I'm simply going to return home and then jump back to the label. So that's all I'm going to do. So let's go ahead and run this program. So again, this program right now has no vision in it at all. It just comes over here, goes to the offset, comes straight down, and then returns. Okay, and I don't, it should be actually returning right to the pupil on the eye there. Okay, so it's just coming down to the origin point on there. So that is the program. All right, and now we're going to add the vision to it. So the first thing we need to do in the vision is we need to come over to our vision setup. Okay, so we need to come over here, and we're going to go to Vision Type, Process Tools, and then we're going to create a 2D single view vision process. And I'm just going to call this like Heart Smile 2 because I already have one here. And I could put a comment in there. And I'm going to double click on this now, and you can see that everything's red in here because nothing's really been said. So now I've already set my calibration for user frame 6. So I need to come here and set my frame to frame 6. Okay, and I need to select my calibration. Okay, so I need to select my calibration here. And so this is my calibration. I may need to adjust my exposure a little bit. Okay. And then we're going to go to our geometric pattern match locator tool. And I'm going to say teach. And I'm going to come over here and I'm going to draw my box just around the smiley face. Make sure that you leave a little bit on all sides of the smiley face so that it has at least a little bit of, in this case, white color around the dark. Okay, and so here you see the smiley face, and you see there's some extra stuff up in here. I want to ignore that, so I'm going to come to mask. Now, a lot of times I say mask everything, but in this case, all I really want to do is just ignore this over here in the top right corner. So the rest of it is actually very unique and very easy to see. And so it matches very well. But I just want to ignore that top right corner. So I'm going to set my mask. I'm going to do a snap and find. And we see there that it's looking very well. And then but notice the 2D single view vision is still not correct, okay? So what I need to do is I need to come over here and I need to set my reference position and hit OK. But I did set, and I need to read the error message. It tells me I haven't done a find yet. So even though I did a find, snap and find over here, when you come back to the single view, you actually have to do a snap and find again. Okay, so you do the snap and find on the single view vision process, then you can set your reference position. All right, and so you can see here that the reference position is minus 14 millimeters in the X, minus 13 in the Y. Now I want to point out that the reason for this is the origin. So if I come back to my geometric pattern match, okay, I laid this down so that the eyeball is pretty much at the origin of my frame. So I'm going to come over here to set origin, and I'm going to set the origin to be the pupil of this right eyeball. And so now when I come back, I'll do a snap and find here. Okay, but you can see that the crosshairs are at the pupil of the eyeball now. So now if I come over here, do a snap and find again, and now I do the set, notice that these values, it's not perfect because, you know, I'm a couple millimeters off from my actual origin. But you can see that the numbers are almost zero, 1.8 and 3.5. So very, very small. So instead of being 14 millimeters off, I'm only less than 2 millimeters off in the X and less than 4 in the Y. Okay, and so so that is my values. Okay, now remember this was called H_smile2. I'm going to save this, and I can end my edit, or I can just leave it open. It actually doesn't hurt to leave it open. But I'm going to come back to my teach pendant. So I'm going to come back to the teach pendant here now, and I'm going to edit my program. So I'm going to come here after this wait. Here's my main loop. After the wait, I'm going to insert a couple of lines. And I'm going to go to instruction. Under instruction, I'm going to come over to vision. And the first thing I'm going to do is run the run find. And my choice there is going to be my H_smile2, which I just taught. Then on the next line, I'm going to go to instruction, vision. But this time, I'm going to run the get offset vision instruction. And again, I'm going to choose my Smile 2. And what happens now, when it finds the part, it's going to calculate the offset and store it in a vision register. A vision register is a position register that is dedicated for the vision processes. And so I'm just going to use vision register number 1. And if if it doesn't find the part, what does it do? It's going to jump somewhere, so I need a label. I'm just going to jump back up here and wait another half second and run the vision again. So I'm just going to jump back to label 1, wait a few seconds, or a second and a half in this case, and then try the vision, take another picture, and see if I find anything the next time. So what we're doing here again is we're calculating the offset for the smile and storing it in vision register number 1, which is a position register. And if we don't find it, we're going to jump to a label. So in this case, I'm just going to jump back to label 1. But if I do find it, then I'm going to move over to that part. But now I need to add the vision offset, because if it's not in the same spot, I need to move to that. So I'm going to go to choice, and I'm going to come over here to vision offset vision register. So vision offset vision register and vision register 1. And I need to do that for each of my 3 points. So remember, I have 3 points. I have the point where I'm up top here, 100 millimeters above. Then I'm going to come straight down, and then I'm going to come straight back up. All 3 of those are going to need this vision offset added to them. All right, so all 3 of those get that vision offset added to it. And so now I'm ready to run this. Now I haven't actually moved it yet, so it should be pretty much right on the spot, right on the money. It comes down here to the eyeball and back up. So I've adjusted the camera a little bit so that we can see more of an angle. All right, so again, it's coming over here. Look at the command. It's at the tool offset, then coming straight down, and then it's going straight back up, and then it's going back off, okay? So, and of course, it's just going to repeat that as long as it finds the part, okay? So we come down here, and you can see, and it's going down there pretty much right on the eye. And so if I scoot it over a little bit, if I move it a little bit, right, it should make the proper adjustment and move on over. Okay. And if we rotate it some, then you're going to see it's going to rotate the tool to compensate. So just tried a couple of different rotations here. Right in front. One more try here. All right, so that is how you set up a single vision process. Okay, So let me just reiterate here. One of the key things that you need to make sure that you do is start by double checking your frames. So go check your frames, make sure that your frames are where you expect your frames to be. Technically your frame doesn't have to match your calibration grid, but it's a really good idea if it does. It just makes things run a little bit smoother. Okay. So the other thing is that you have to make sure that your grid has been calibrated and not moved on you. And then you create your program. So the program should just like go over to the part. It should use a proper tool offset before approaching the part so that it comes straight into the part and then leaves again straight. So remember, these are linear straight down from your tool offset straight down to the actual point where you would be, your tool center point would be on the part where you want it to be to open or close a gripper or process the part, whatever you're doing with it. And then return to that tool offset and then move off to wherever that you're going to be returning. So you write the program, just an ordinary program without any vision. Then you teach your part. So you come in here, right? So we would come in here, we would create a new part if we needed to create the new part. And then we come in here under the single view process. The first thing we had to do was choose our calibration. So we make sure we choose our calibration. Then we come in here, we teach our part, okay? And I don't want to reteach it at the moment, right? But we go in, when you teach the part, you select, make sure that you leave a little bit of area all around your part in your teach box. And then if you need to, you may have to come in and mask out some areas or mask out most of it and then just unmask the parts that you care about. If you wanted to, you could do, an emphasis area, just like we discussed before in the previous videos. And then, you can adjust your thresholds and that kind of stuff as necessary. But then you come back to the main single view. You do need to do the snap and find. And then when you do the snap and find, then you need to set your reference. Okay, so you need to set that reference point. So to do that, like right now, if I set this, okay, you can see these numbers are just out of town. Okay, so remember, to do the snap and find, you want to really put that part right there, line it up on your origin, okay? And line it up on your origin and do the snap and find. Okay, as you can see now, I've got that lined up pretty well. And then do the teach, and you see here that was even a little bit better there. I've got my X reference down below 1 millimeter and my Y reference down below 3 millimeters. Okay, so you really want to have that as close to 0 as possible. One way that I recommend doing that is if you actually have a gripper attached, is turn the gripper on and have the gripper place it at the pickup point. So actually kind of put the part in the gripper exactly the way you want to pick it up, and then run the program without any of the offsets. Run the program to have it move down and place the part exactly where you want the gripper to be grabbing that part at. Okay, I don't have a gripper currently, so I can't do that, but that's what you want to do. If you have a gripper, make sure you place it in the gripper just the way you want it, and then run your program just to the point where it puts it at the pickup point exactly where it should be, and then manually release the gripper and back the arm away so that you can then take your picture. That's when you should actually take your picture for the teaching section. All right, and that way your reference should be virtually perfect. And then make sure you save that, okay? And then when you don't actually have to leave it, so you can leave this open while you're testing it. Just make sure you save it anytime you make any changes in here. And then I'm going to exit without saving now because I had it working pretty decently. And that is the program.